7-3 Part 1. This particular lesson is the introduction to special right triangles. So, thinking about special right triangles, a lot of people get really confused about special right triangles. They're just shortcuts. They shouldn't be confusing. They're actually to make your life easier. They're used all the time throughout advanced trig. They actually, like I said, they're shortcuts. They should make your life easier, not harder. On number 1, when it says to draw a large and clearly labeled diagram, you want it big because it's easier to write in the angles. So just make sure you don't make it tiny. You can see I'm going to make a pretty big one. The 45-45-90 degree triangle, which is this one, is the one that's used more often kind of in the real world setting because it's half a square. Basically a 45-45-90 triangle is what happens if you cut corner to corner a square. The two legs are the exact same length. So whatever one leg is, the other leg is. The hypotenuse is the leg multiplied by root 2. So if the legs were 5, the hypotenuse would be 5 times root 2. If the legs were 10, the hypotenuse would be 10 times root 2. If the legs were 15s, the hypotenuse would be 15 times root 2. It makes it really fast because you don't have to go through and use the Pythagorean theorem. You can just use the shortcut. In general, if you are going from the leg to the hypotenuse, you're going to multiply by the square root of 2. The square root of 2, by the way, is 1.414 approximately. It's rounded. The square root 2 is the literal length of the diagonal of a 1 by 1 square. It comes up a lot in math. For a long time, they actually didn't think that square roots existed, that they would always reduce to nice numbers, and they discovered that that wasn't true. And it was like a well-kept secret in a math cult, in the Pythagorean math cult, that you couldn't actually simplify them because it kind of screwed up their whole religion. So if you hate them, you can join them and just kind of keep it a secret and pretend it doesn't happen if it screws up your religion. Okay, so going from a leg to hypotenuse, make sure you multiply by root 2. If instead you're going backwards, this is very intuitive in some ways. If you have the hypotenuse and you're going back to the leg, you just divide whatever the number is by root 2. Your calculator will just let you multiply by root 2 or divide by root 2 and just give you an answer. You're just figuring out what the shortcuts are. So that's the 45-45-90 triangle. So number 2 is doing the same thing with the 30-60-90. The 30-60-90 is a little bit more complicated, only because none of the 3 sides are the same. I use this one probably more than people do in real life. Where it comes up is a 30-60-90 is actually half of an equilateral triangle. And equilateral triangles are fundamental building blocks when you're building hexagons, which are often used in gazebos and things like that. So they are used, they're just not used as often. Usually people build things rectangles and squares versus triangles and hexagons. So with that being said, it is a shortcut. So the hypotenuse is twice as long as the short leg, and the long leg is the short leg times the square root of 3. When you are solving these problems, the big hint to make your life easy is always find the short leg first. You have to know what the short leg is. This is the important one because that's the one that's x in the formula. Once you have that, the other ones are pretty easy to find. So if they already give you the short leg, awesome. if they give you the hypotenuse and you have to go and find the short leg, you just divide it by 2. Because what this diagram means, the 2x there, means that it's twice as long as the short leg. If they gave you the long leg, and you need to get back to the short leg, you divide by the square root of 3. Once again, your calculator will do those weird divisions for you. Once you have the short leg, it's easy to find the other 2 lengths. If you have the short leg, or found the short leg, and you need to get to the hypotenuse, you just double it, or multiply by 2. Right? That's the opposite of dividing by 2. To get hypotenuse to short leg, you divide. Short leg to hypotenuse, you multiply. That should make sense. And to get from the short leg to the long leg, you multiply by the square root of 3. So let me do some examples of this. So this would be our other notes section. Example. The diagonal of a square is 6 inches. What is its side length? The diagonal of a square is 6 inches. What is its side length? So square, diagonal. When in doubt, always draw a picture. I kind of already told you this, but if you're talking about the diagonal of a square, you're talking about those half of a square. We're talking about a 45, 45, 90 triangle. They told us that the diagonal was 6 inches. So what we know is that the hypotenuse equals 6 inches. And I need to go to the leg, and to go from hypotenuse to the leg, you divide by root 2. You just look that up off the front if you don't remember. So 6 divided by root 2, you can stick that in your calculator, and it is 3 root 2 inches. Obviously that would be difficult to measure out on a ruler, which is why you have that button above in your calculator to turn that into a decimal. Example. Find the missing sides I have a triangle. It is a 30, 60, 90 triangle. I know that the long leg is 12 centimeters, and I want to know what the short leg is and what the hypotenuse is. You do have to recognize that it's the long leg that you have. So as I told you, always start by finding the short leg. So to get to the short leg from the long leg, you would divide by root 3. So x is the short leg, 12 divided by the square root of 3, which is 4 root 3 centimeters. And then to find the hypotenuse, I go from short to the hypotenuse. I want to times by 2. So 4 root 3 times 2 is 8 root 3 centimeters, and the hypotenuse they called y. So there are your notes for 7-3, part 1.